Greetings, the Astro 30 here, broken drill bit, and this is probably going to be the last video for 2018. Don't worry, there'll be more in 2019 after I've moved. Now today I'm going to look at this plus minus 15 volt universal power supply kit, Jaycar catalog KC5501. And it was made by Silicon Chip, or published by Silicon Chip magazine in March 2011. Now you may be asking yourself, why do I have a 15 plus minus power supply here? Well, I'm always forever testing operational amplifier circuits which require a split rail 15 volt supply, and even though I've got a bench supply capable of doing it, it is a little bit of an annoyance when you want to power an op-amp circuit and then power a higher powered circuit from the same supply. Say, example, you're designing and building a little preamp on breadboard and you want to put it into a power amplifier, and you want to run the power amplifier at a different voltage, obviously. So this is where a second supply, which is just dedicated for providing plus minus 15 volt all the time, unadjustable but regulated, is what the go would be here. So let's open up the kit and we'll have a look at the instructions. So this was about $17, $18, something like that. It wasn't that expensive. So there's the instructions, a bag of parts. Comes with a couple of LEDs here, 3 of them by the looks of things, using Suntan brand, 22,000 microfarad, 25 volt, so keep that in mind of how much power you put into the unit. And a little tiny cute circuit board, and it just uses a 7815 and a 7915 respectively. Now they call it a universal supply because it can be built 2 different ways. You can build it as a single-ended, or you can build it as a split rail, as I intend to. And you can also change the voltage regulator that you use. You can use a 7812 or even a 7805 for all it mattered. And the only difference with that is you'll notice over here they've got like R1, R3, etc. and up here as well. These values are chosen for your different voltage inputs. Now they're using a 15015 volt transformer to power this circuit, and that's what I would stick to. I wouldn't stick an 18 on there because remember, those caps are only rated at 25 volts. You will eventually blow the arsehole clean off of them. So I actually do have a 15015 volt toroidal transformer sitting over there, which I'll demonstrate in a moment, but this is the schematic for it. It's very simple. We've got a power indication LED here, which I probably won't use, and you've also got output indication LEDs here, which is handy because I want to build this into a case, and I do actually want to have 2 LEDs to display that each voltage regulator is outputting a voltage. And the reason I would have those there is because when you start drawing current on here and one of these shuts down because you've either short circuited it to ground, if the LED is not lit, well then you know there is a problem on that circuit, so you can turn it off. Now when all said and done and put in the case, I did think about putting a load on off switch on it, but I don't really see the necessity for it. Probably would be an idea to have it, but it can always be added later. However, that's the circuit. There's not much to talk about. It's just a simple 7815 and 7915 respectively voltage regulators across a split rail supply using a full wave bridge rectifier, consisting of 4 1N 4004 diodes. So the whole entire circuit can draw no more than 1 amp. So, but that's okay, because for op-amp circuits I don't need more than an amp. Correction, it can be built 4 different ways. We've actually got full wave rectification here, just using 2 diodes and a center tap, so you would end up with a 12 volt output off of a 12-0-12 center tap transformer. And the same over here, you can use, well, this is not a full wave rectifier, these are 2 half wave rectifiers. So one, the positive side is being rectified by this diode going into here, and the negative going half is being rectified by this diode going into the negative regulator. But why you would need to do that with just 2 diodes when you've got position for 4 is really beyond me. And they're just saying down here in this little blurb here that these 2 diodes, D1 and D2, are being used as a full wave voltage doubler. We've got what the board looks like in final photos, the overlay diagrams or component placement diagrams for all 4 different configurations. This one here, the first one, is the one I'm going to be using, so all the components are going to be put where they are. Apart from the first power indication LED, I don't need it. So all I'll be doing is LED 1, LED 2 on the outputs. So now the next question is, would I want to put heat sinking on this? Well, probably. So what I'm going to do is burp, and I'm going to put this into, well, I don't know if I can even fit it into my tool. I was going to say I was going to put it into my tool, but nah, I don't think I'll bother. What I will do is I will start mounting components on it and get the thing built, and then we'll you know, see from there. Now the thing with calculating the resistor values for the current limiting resistors for each of the LEDs is, well, the simple formula of this is the resistance equals the voltage coming in, which is the main supply voltage, VDD, minus the voltage of the LED divided by the current of the LED. So you need to know what the voltage of the LED is, and you also need to know what current draw the LED is, and then you can work out the power rating of that resistor that you need. So it's not that hard. So that's how you would calculate that, but you need to know the voltage of the LED and the current of the LED. Now they've helped you out there anyway, and assuming you're going to use the 5mm round red LEDs that come with it, they've calculated for the different output voltages that you're going to be having there with regulators. In my case it's the plus minus 15. You need a 30 volt AC transformer with a center tap, and you're looking at 1.5k ohm as the limiting resistor. So we'll stick to around that. That should be fine. I'm going to change them to 3mm LEDs. Remember, there's going to be a slightly different voltage drop with a 5mm LED as there is with a 3mm LED. What those drops are offhand, I don't know. Okay, just before I get started with assembly, I wanted to just clarify something with this schematic. D5 and D6 here are known as protection diodes or flyback diodes. What they do is they protect the regulators against asymmetric loads. That is, that the positive or negative rails get pulled in the opposite direction during switch off, which can then inject the voltage back into the opposing regulator, causing internal damage. So that's what those 2 diodes are for, basically to protect the output of each of these regulators. So I've got the board mounted in my shitty helping hand tool here. So what I'm going to do is I'm going to assemble this board in the dual rail configuration apart from LED 3 and R3. I don't need them. And I'm going to do that in time lapse. Why not? So let's get started. Okay, so I've installed everything by the regulators here because I want to fit them to heat sinks, and I've got some decent sized heat sinks for them. They're just going to hang off the edge of the board a bit though. You notice I've shoved in these two-way connectors either side for the LEDs just to make it easier to connect them to it. So as for heat sinks, my light is in the way of the drawer. Well, I do have these rather large PCB mount style ones, but they're going to be way too big. So I'm going to stick with just two of these. They'll do the job just nicely. They don't necessarily need to be isolated from the device, but it would be handy to actually put them on the device. I'm going to mount it that way so the fins are sticking out the back of the device, not trying to force it in. So I might mount these heat sinks to the ICs. So a bit of Augustus gloop, not too much Augustus gloop. That's a Charlie and the Chocolate Factory joke. Oh shit. I mean, really? It's not that hard of a concept to do, but because it's of its fiddliness, it becomes a hard concept to do. Alright, so I need to tighten those properly, but I need to clean my hands with my screwdriver. Penis. Okay, tighten that one. And just throw it away. Tighten that one. Find out which one is which. That's the 7815, which goes in that hole there, facing out from the board, i.e. the heatsink area faces out. And this should be the 7915, which is over the other side and faces out again respectively. That one had a little bit of Augustus gloop coming through on the lead. Soldered properly, and there we go. The module is built, regulators at a reasonable height. So now to trim off the excess lead here. Now the only thing in this kit they didn't give you was standoffs to mount the board into something like a chassis or, you know, a plastic case. So I'm going to need some standoffs, but first, well, I'll put the standoffs on, I've got plenty of them, but first I'm going to have to test whether or not the thing actually works. That'd be a good idea. So I'll test it on a DC supply before an AC transformer, because that way I can current limit it if in case there's a short circuit. Then we'll just have a look at the output, see if we've got plus minus 15 volt. We won't see any LED indication, but we don't need to. Okay, we're ready for testing. I've got it hooked up to the DC power supply off to my left here. Got it set to roughly plus 20, minus 20 volt. Might be a bit high, I'll take it down to about 19. That way I know that because these power supply rails are imbalanced, I don't want to exceed the values of these caps or they will explode in my face. You guys may find it funny, but at the time it's not. Now, got the meter ready to measure the output, so I'll turn the load on and see if everything goes off with a bang. No, and there's no unusual current draw on the power supply here, so I'll just check the positive output. We have plus 15 volts, negative output, negative 15 volts. There's about a difference of, I want to say 90 millivolts, something like that. But yeah, it's pretty close, so we know that that's working. Our input voltage is 21C. I've reduced it down to 19.7. I'm still getting 21.5 in on one side and 19.5 on the other. So that was a good idea to reduce the supply. So now I know that that works on DC. It shouldn't take that long to discharge. In fact, it's falling off quite rapidly. So that's good. I found the nut that fell on the floor too, so that's alright. Now, what to do next? Well, the answer to that is simple. I've had this case knocking about for the last 2-3 years with the intention to build a, well actually I was going to use it for the frequency counter module that I had, but today it's going to be used for this. It's the Jaycar Catalog HB5912, and I think this one was $20. Anyway, it's 200 millimeters long by 158 deep by 64 millimeters high, so there's plenty of room in there to mount a toroidal transformer. Yes, the size of the case is a bit big for a little module like this, but yeah, it will serve its purpose anyway. So I'm not going to cut any aluminium front panels or back panels with this. I'm just going to use the plastic ones because really I want it electrically isolated from ground anyway. There's the screws for it. There's all these standoffs in here for mounting PCBs and shit, but of course the transformer's not going to fit in here with all this crap here, so I'm going to have to actually grind it off. Unfortunately, my little mini grinder, I can't use a cut-off wheel. I can use a grinder wheel and grind them down, but it may take all day. But we'll have a look at that. Next, I've got some banana post terminals, an M205 style fuse holder. I never could find these when I wanted them, and all of a sudden they just appeared, so they are there somewhere. A switch that's illuminated, little red neon there, push in, push out. I had one of these switches knocking about, which I was going to add to the DDS, but for the life of me I cannot find the sodding thing. It's disappeared completely. It was put on top of a shelf and then buggered off somewhere, and I haven't seen it since. Looked everywhere, can't find it. Who knows? When I move out I'll probably end up finding it. So I got that, and I've also got this transformer, which is an MT2086 15 plus 15 volt 20 VA toroidal. So when all said and done, you're looking at about, with the windings wide in series as the in series as they're going to be, you're looking at about 1.3 amps thereabouts, which is more than enough to power the circuit board. So I'll move this to the side and we'll open this box and we'll have a look at our little transformer. So it comes with its mounting gear, which is good because there's nothing worse than getting one of these transformers and it doesn't have the sodding bolt in it. Now, they normally do print on here what the primary side fuse is supposed to be, but they haven't, so that is a pain in the ass. So I may have to look that up. I reckon it'll be around about an amp. Slow blow. The plastic insulation on this is pretty badly done too. It's yeah. Anyway, so that's going to go in the case. Stuff in the case somewhere here, so I'm going to have to piss off all of this shit here, and I might not have to worry about those ribbing, this ribbing here too much, because the rubber condom that comes with the the rubber washer that comes with the thing will probably take up that area, so it's not too much of a big concern. Interestingly, the two primary wires are both blue. That's that's interesting. Anyhow, there's no wiring diagram for this either, so usually I'm pretty sure though it's orange and yellow are one secondary and the red and the black are the second secondary respectively, but I'll look that up whilst I'm looking up what line fuse to put in series with this transformer. But I guess first thing to do would be to get rid of those standoffs around about there, because the PCB can then mount somewhere over here. I'll just drill through the case, no worries. And yeah, so right, let's get going. Real cases, real people, Judge Judy. No, well, the mini angle grinder made really mincemeat of that. It got the standoffs cut down that I needed to. Yes, it makes a bit of a mess, but it's the inside of the case, and you don't see it on the outside, nor did it warp it too much. So that means now the transformer should sit nice and flush up against the case, of course with its rubber isolation condom around about there somewhere, and that'll be just perfectly fine. Just got to remember to leave enough room for the AC power cord to come in and my fuse holder, and plus to deal with all the wiring. So whilst I'm at it, I'm going to mark where I need to drill the hole for the transformer, and that'll be the next step. So yeah, the grinder tool is still useful for grinding stuff, but just not cutting stuff anymore because, well, the cut-off wheel screw broke. Not much that I can do about that. Okay, so let me just, that's about a 5mm hole. Let me just drill this hole out, and we'll actually get the transformer mounted so we can actually see where we're going. And I just used one of these wheels here to grind it down. I was just doing it like, you know, that way, but whatever works. I could have sat there with a saw blade and cut them off, but yeah, whatever. Okay, I'm going to start with a 2.5mm pilot hole about there somewhere, and then I'm going to change up to, I believe it's 5, so I'll just check that drill bit with that. That's probably smaller than 5, but we'll say 5. Probably more like 4.8 when all said and done. It wasn't that bad. So, rubber thingy, washer. Now, it should go the bolt. Now, one would think that we'd normally put the washer on top of the cup before the spring washer, so the spring washer going last, but this cup is basically a washer, so I'm going to use the washer on the bottom, and yes, 5 is just big enough. So there's that. Transformer will mount so the wires are going closest to the back. Second isolating washer, the cup, the spring washer, and finally the nut. And I'm just going to loosely do it. I'm not going to tighten it yet. That's good enough. That just gives me some reference point there of where things are, and it looks relatively okay. It's fine to me. Now, next we'll be working out where to drill the holes for this board. So, the easiest way would probably be to take those standoffs out, but then I would never get through. So, probably let's measure it and find out. So, long ways, we're looking at 63 by 27. So I sort of have to visually guess this because I won't be able to get a square in there. So that's going to be my 2 holes there by 23. I mean, sorry, 27. I mean, this is as accurate as I get. We're looking about there. And there. And they're going to be roughly in the same places. So again, I'll start with 2.5. And if I have to oversize the holes to like 4mm, so be it. But let's face it, it's not overly critical at this stage. Alright, so I got rid of that wood block that was under there for a sec because I don't need it at the moment. Oh, how well did I do? Oh, look at that. That is not bad at all. Not bad at all. So, for that, what I would do is I believe 6mm screws are long enough for this type of application. Yeah, just. Okay. Do I need a washer? Yeah, I'll put one there anyway. I've got plenty of them, so might as well use them. Okay, just sort of like hides the ugliness of the hole. Although it's the bottom, no one's going to see it, yes, but it just looks neater in the long run. But if I was that real fussed about neatness, I would have drilled the holes properly. That is, I would have measured it properly. I did not. So I'll get the first one started. Okay. Oh, it just sits there nicely with the weight of the transformer. Another screw. Come here, you little prick. When you want one, you end up with three. Okay, so put the screw into here. Same again on the other two corners. I've just lost the washer where it doesn't belong. Okay. When they go in just nicely like that without bowing or twisting or binding, that's pretty good accuracy of measurement when you're just guessing. That's all I've got to say. No binding, no nothing, and we can tighten them up, and it's not pulling anything non-square. Don't want to over tighten these because the standoffs on the other side will be pulling against the plastic, which will also be trying to sink it into the plastic, so it only just needs to sit there. So that's fine. We've got a front panel, we've got a rear panel, once I can get it in the hole. Get in the hole. Story of my life. Okay, there we go, and then you put the top on like that. But of course, we're going to need some form of feet on the bottom of it to stop it scraping the shit out of the desk. So I've got these. There's actually four just handily sitting here. So I'll take those back out now. Actually, I might leave them in there because it'll be easy turning it upside down. That's backwards anyway. Turning it upside down and getting it flat on the desk. So, oops. Okay. Like so. Because basically all I need to do is clear the depth of that, and these are 10mm, I believe. Or are they 8mm? Let's measure it. These are more like 8mm, but that doesn't matter a shit. So these are self-adhesive, so I'll put one here. Bit crooked, yes. One here. One, if I can see what I was doing, there, and finally one there. So when I now turn it over, there we go, that's that done. So now with all that, we need to work out what the hell fuse to use for this transformer, and if I was right saying yellow and orange is one secondary, black and red is the second, I'm pretty sure it is pretty standard. It's not marked on the box, it's not marked on the transformer. So I need to look this transformer up. Well, that'd be right. There is no data whatsoever when looking up the catalogue number of this for this transformer, and there's no part number on it. Except it does say on the box P28604, so maybe if I look that number up I might get somewhere. Right, so looking at some other data of other transformers of a 30 VA anyway, it is going to be orange and yellow is one winding, red and black is the other. The primary fuse should be no more than about half an amp, so 500 milliamps, slow blow. So that would sound about right. Now, as to which way these are wired so they're in phase with each other, well, they do say on the transformer it's got 15 volt AC times 2. So you would assume, because it goes red black for one winding, yellow orange, so you would assume the black wire is the 0, the orange wire is the 0, the red is the 15 and the yellow is the 15 respectively. So here is a crudely drawn diagram. Currently I've lost my eyes, my glasses. We got our active and neutral across the primary, and BL means blue. They're both blue, one should be brown, but it doesn't really matter for this demonstration. But we'll say the neutral point is there and the neutral point is also there. So it goes through a 500 mA slow blow fuse. I think I've got one somewhere. If not, I'll stick a 1 amp in there and change it later. So the red is going to be 115. The black of that same winding is joined to the next one, the yellow of the second, which is the other 15, so that's a 015. And then finally the 0, the orange wire, forms the other side. So the neutral side, that would be the active side, that will be the 0 side. So it'll be 30 volts here, 0 there, 15 there, theoretically. So if you've got it wired correctly in the correct direction, if I could speak, it'd be nice. If you've got it wired correctly, it should work properly. Now if you've got these wired out of phase, well, just like any AC signal, it's going to cancel each other out, probably destroy the transformer too. And it just simply won't produce any voltage. So, with that in mind, we can take these crappy things out that I had in there for testing purposes, and we'll try this theory by connecting our red to one of the AC inputs, orange to the other AC input, so the other side, okay, and then join these two together in the center to form the center tap of the transformer. So hopefully I can get both these wires in here. Yep. Now to make it easier, I'm going to put a ground connection to the meter output so I can measure it quickly. That did jack shit. So does that. Sometimes I hate these terminal connectors, and I'm sure ye bastard, they hate me. Right, you can fuck off and I'll use a thicker wire then. Yes, I swear, and I don't care. Hey, that rhymed. Okay, we've got a connection for a 0, so that gets connected to there. and the negative of my multimeter, and that gets turned on to voltage scale, and then I've got this one free to just go boomp, well, boomp, boomp, and I can also do AC tests as well, or even DC. So what I need to do is hook up a power cable to this. I've got one somewhere that's like just a 2-core connected to a terminal block. I think I know where that is, just so I can plug it into the wall. Right, so this is the power cord I'm going to end up using on the toy anyway, I mean the project. Now the only thing with this having 2 blue wires is not knowing which one's the neutral side of the transformer. And sitting on cushions on chairs is a pain in the ass when you want to slide across carpet. Okay, so I need to connect these wires. I might as well use this terminal block too, just to mount my wiring to from the switch back to the transformer, etc. So if you're doing something like this at home, if you don't know what you're doing, don't do it. I have really I wouldn't say extensive, but I've got a fairly hefty experience with using toroidal transformers, and they're usually always the same, and usually use the same wire color coding, albeit this one's yellow instead of white as on a 30 VA transformer, and a lot of other transformers actually have it marked on the body which way around everything is, but this case I don't have that luxury, so I'm not going to sit over it. I'm going to plug it in. If anything goes bang, we'll know about it. Nothing went bang. Measure the voltage. Positive 15, negative 15. So across our bridge we've got 22 volt. So that's on, yeah, which is about right. Should be negative, nothing there. So that forms our positive side. So we've got 22 volt. So that should be, with respect to ground, plus minus 22 volt. So there should be on the other side, if I could figure out where that was. Is it there? Yeah, there it is, minus 23. Stay on there. Stay on there. Minus 23. So we've got roughly 46 volts DC across both positive and negative of the bridge rectifier. So this is where I was measuring from. I was measuring with respect to 0. So I was measuring from this diode string here, this cathode to anode. That's not right, sorry, these two cathodes. On the positive side, it says here it should be 20.5 volts between here and 0, and 20.5 volt between there and 0. It's actually more like 22, 23. So we're coming very close to exceeding the ratings of these capacitors. But for all intents and purposes, it is actually functioning as it should. And as I said, we've got that's AC side, you dickhead. Positive 22 volt there with respect to ground, and minus 23 volt with respect to ground there. So it's a little bit imbalanced, but it should do the job. But yeah, 23 volts is coming very close to exceeding the 25 volt rating. I've actually destroyed a 25 volt cap with only 24.5 going into it, so yeah. But we know that the transformer's wired correctly, because if it wasn't, we wouldn't have that negative voltage or positive voltage, we would have no output. Therefore we know that this is wired correctly in phase. And yes, don't go grabbing live AC wires with your fingers unless you know what you're doing. And so all I've got to do now is do the front panel, drill out the rear panel to mount all the other crap like the fuse holder. Fuse, I'm not so sure what I'm going to do about right now, but I'll figure it out. So I'll unplug it for now, and yeah, we'll keep moving on. Alright, so I've doodled up a quick front panel here. I haven't drilled it yet. Yes, it's not exactly mounted nice and straight, but it's not really important. It just serves the function of what this thing's do. And with this switch, I just realised it's an LED based one, not a neon based one, so it requires a 2 volt voltage at the positive negative inputs for the LED, so there's no dropper resistor in here. But that's handy because on this board we've got a space for an extra resistor to do for the power LED. Just means that I'm going to have to calculate what the dropper resistor is for that. I'll get to that lastly. But firstly, we'll put our front panel in, and yeah, it's rough and ready, but they'll look reasonably okay with the top on. So all I've got to do is just drill out my holes, mount the components I need to. I'm probably not going to worry too much about spraying any lacquer on this to protect it. I mean, it's just a supply. So yeah, we'll get to that. That appears to be bowed a bit. Anyway, drill those out. I'll glue the LEDs in last with some hot glue once they're wired to the connectors to go to the board. Then we'll wire up the AC, power switch, LED for its indicator, and all that fun stuff. Okay, front panel's drilled. I'm just putting some hardware on. That's what it looks like so far. With these, it'd be really nice if they came with the tag strips to make soldering wires to them easier, but they don't. Also, before tightening these nuts, undo this end, so you know you're not trying to undo it once it's tight and then just undo the nut on the other side by accident. So these don't have to be overly tight, just tight enough to stop them turning. There is location pins in them to hold them into the panel so they don't spin round, but of course I've got no way of manufacturing that. So, but that'll do will serve the purpose that it's supposed to. They look quite nice on there actually. I've decided to go with these 3mm LED clips because, well, they'll cover up the rips in the paper and make it look a little bit nicer, even though nice is not a word. But yeah, it is now. So I'm just going to use 2 standard red LEDs like that, 3mm. What I should do is actually test that the brightness is about right for these LEDs. Going on the current resistor values in there, 1K5. Turn that on. I will connect an LED. Well, it's not very bright, but it will certainly serve the purpose. I've got that the wrong way around, you dickhead. Okay. Red's okay, but let's try different colours because different colours have different forward voltages. So I've got green ones as well. So I'll just try a green one and see if it's brighter. It probably will be. Oh yes. I'm going for green. I mean, I can't hold it on there, it won't stay there. Yeah, I'm going to go for green because it looks brighter and it looks nicer anyway. I mean, have a red power switch and, well, 2 green LEDs. With that in mind, however, I need to know, with this power switch, what sort of resistance to use. Okay, so to calculate the resistor I'm going to need for the dropper, for the current limiting for the power switch, it's the voltage DD minus the LED voltage, and I know what the LED voltage is. It's 2 volt, and according to the specifications on it, it's a standard 5mm red LED. Now, if I look at the schematic for the version I've built, R3 goes between negative and the cathode, of the LED, and the LED is mounted to the positive, so you've got the full DC voltage across this circuit here, which is roughly 44 volts, we'll call it that. So that is 44 minus the voltage of the LED, which is 2, which equals 42, now divided by the current draw of the LED, which is roughly 20 mA. So 42 divided by 0.02 equals 2.2K. That should be fine and dandy for what we need. And funnily enough, supplied in the kit is two 2K2s. So I know that that should be roughly the right resistance for the dropper for the LED. So I've got to pull the board back out to install the resistors. But I've also got to install another connector here. But for now, I can start thinking about wiring some wires off so they can go to this side of the board, wire the sodding bloody connectors for the LEDs, and wiring the power switch to the mains. So I'll get busy doing that, and we'll come back when I've got something a little bit more interesting to show you. Okay, so with the power switch's LED hooked up across the power supply with a 2K2 dropper resistor, let's plug it in and see if it lights up. Indeed it does. I don't know how well you can see that on camera, but it is indeed glowing. So I know that that will work just fine. So now, moving on to the next thing, which is playing with my dick. No, I've done that already. Doing the other two connectors for the other two LEDs here for the output. And then we can move on to doing the back. Black and blue. That's the negative side. That's the positive side. Okay. So now I can test that the LEDs light up. Well, one does, the other one doesn't. It does now. I've got a dicky connection. Okay, so I need to address one of these connection points here. Oh, I see the problem. It's this brown one. I forgot to unplug it, but yeah, now both LEDs are working and the connections are good. So I'll unplug the right power lead this time, and I haven't connected up the power lead yet, but now I can hot glue those LEDs in. So I need my hot glue gun, wherever the hell that is, and pray for a miracle. Look at these LEDs. Oh yeah, lovely. There's plenty of it. It's only cheap stuff anyway, so get around the power switch to stop it from unscrewing or moving. Don't have to go too mad with the stuff. So I'm around these connector holes. Okay, that should be good enough. Alright, so now we're nearly ready for doing the final holes on the back panel for the power cord and the fuse holder and the a hole just to hold the what's it called, this thing, terminal block, and that's basically the construction of this thing done. I bent the heatsink on that, so I'll bend him back. Perfect place for it to go whilst we're doing this. Just a little bit, just to hold the wires up against the cap or capacitors. See what that's like when it's dry. So this lock can be screwed in now. Once I do the next stage, which is doing the drilling at the back panel. It's getting fairly late in the day and I really want to start drinking beer. Oh yes. Anyway, that hot glue is now nice and hard. Nothing should move now. So I can then just unplug my hot glue gun and put him to the side to cool, and then I'll put it away. Alright, I got my panel holes drilled for the cable clamps. I have to take it out of my terminal block just to get it in here. So I'm going to need to get over to this hole here where the terminal block is located, so it's got to go around itself. So that's about there, that long. It still gives me about 1.5 meters of cable here, so that should be fine. Might have to hot glue this in before I finish, but I'll try and get it in there. Yeah, that's actually a nice tight fit. I didn't go too far with that. I'll still put a bit of hot glue on there just for safety. Now the fuse holder, got one nylon washer. I'll put it so the terminals are facing up. Hole's probably a little bit too big for it, but yeah. So see how good I am. I will right, that should be tight enough. Okay, everything's wired. I've got the switch wired into the fuse holder going back to the active in from the power cord, the neutral of the power cord going directly to the transformer, and the switch returning back to the other side of the transformer. The fuse holder has got a piece of heat shrink over it with a couple of cable ties just for extra safety. And all I've got to do now is find a suitable fuse to put in the fuse holder. Okay, so I don't have any small fuse in a 3.15 amp, which is a strange value, or a 5 amp slow blow, so I'm using a 3.15 for now for the test. It's way too big. I need about 500 mA, so I'll have to go out and buy one later, but for now, to get it working, we'll stick with 3.15 amps. Plug it in. Yeah. Look at that, power supply comes on. Supply comes on, supply goes off. So that is working. All I've got to do now is hot glue around where this power cord comes in on the inside to stop it from pulling out because it is moving around. Tidy up the floor, and yeah, the desk maybe. But we got progress. Okay, hot glue gun is hot enough now, so I'm just going to ram some in there. Don't need to go overboard with it, just enough to hold it. That should be fine like that. All this hairy crap. It's the only thing I hate about hot snot is when it does this shit. But anyway, so I could probably check that. Yeah, that should be fine. Okay, I can put the top on now for the first and last time. So this case is finally being used for something. So I'll turn it over and I'll put the provided screws in it. Oops. And voila, it is completus. So here's a look at it from the perspective of, as you'd be looking at it on the bench. There it is, all completed. It looks a little bit sparse, yes, there's no meters or anything on it or anything interesting, but the point is that is not relevant. The relevant point here is that it's functional. So plug it in and turn it on, we can see that it works. And if I was to hook up my meter to it, I mean, I should hook up a load to it to test it properly, but I don't have anything suitable. So, positive side, positive 15 volt, negative side, it's negative 15 volt. Perfect, that's all it has to do. And yeah, it took me all day to do, but it turned out reasonably well. I mean, yes, that's paper or self-adhesive sticker, and will eventually probably come off, but will serve the purpose for a few years. Like, you know, I just wanted to power up a bunch of op amps when I'm doing circuits such as that. But anyway, I'm going to end this video here, and if you enjoyed it, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter, the links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, Happy New Year.